Hello everyone. Today we are going to discuss about the two categories of machine learning problem. This is really important to get started with machine learning and they are very easy to understand too. So they are called regression as well as classification. We'll go into details with the example to understand more. So let's take the example of classification. Like anything we say, if you want to classify from a known set of data, for example, you want to classify from a three animals you have, right? So like dog, cat, or rabbit. So in your training data, you have examples for these three types of animal, and the output parameter is either of these three, right? Then that is called a classification problem. Similarly, there is a binary classification scenario too, where your output is only two, right? So either a spam email or not a spam email. But the general idea is it's a small set of output which you know and you are trying to predict. Now, when it comes to regression, always it's a number, and you are trying to teach it a set of numbers so that it can predict a new number. For example, the weather tomorrow. You are trying to give examples of weather data for few days in a range, and then the next time it is going to predict another number, right? So the number it is going to predict is not from a small category like the example you have seen for classification, right? So that's the concept of regression. Another interesting thing is any of these problems which are regression, you could even convert it into a classification. So for example, our temperature case itself, you can think of maybe it as a classification problem by putting the temperature as two. One is warm and one is cold. So you say till 25 degree it's cold and above 25 it's warm, right? And in case of classification, you are trying to find, maybe in case of binary, two numbers, right? So usually we try something called sigmoid curves, and there are other algorithms too. But in case of regression, especially linear regression, it's a continuous line. So with that, whenever you see a new value, it's going to see from that line how you can plot the value of y. I thought there's an interesting thing we can look here is if you want to see how a machine learning model learns. So the same example of regression which we saw there is shown here. You have your data set plotted here. Now we are trying to draw that line. So if you can see every set of data it's trying to learn, and at the end it is just trying to make a line which fits all these dot points. So you can now slowly it is trying to move up, and after multiple iterations of cost reduction, right, that's something called gradient descent. So it's trying to reduce the cost, and finally it will find a optimal line for which all these dot points cost is the least. And now coming back to our presentation, so for classification, one of the examples is called logistic regression algorithm. So let's first think about regression. So regression, it's pretty straightforward. Like we see in that example, it's trying to draw a line, and the formula for line is x into w plus b, right? Where w is the weight and b is the bias. So that is what we are trying to learn by iterating through the data. In case of classification, similarly, we will first draw a line, then we will pass it through a sigmoid function so that that line is now between two values 0 and 1 in case of a binary classification, and the output is an S curve. So I hosted previous videos about both of these algorithms, and we are trying to implement them from scratch. So I will link these videos too so that you can understand how a logistic regression and a linear regression is implemented, right? I hope you understand this concept, and it takes some time initially, but it's very easy, and this could be a starting point for your journey in machine learning. Thank you.